Hello everybody, my name is Piotr Bazydło. I'm a vulnerability researcher at Trend Micro Zero Day Initiative, and today I'd like you to present my research concerning .NET deserialization and serialization. So basically I'm going to show you how I was approaching some hardened targets. So first of all, I have to mention that I have material for like a 2-hour-long talk, and of course you don't want me to talk for 2 hours. So I have written the white paper. It will be public in 2 days. So during the talk, I'm going to present you some general ideas and some examples. But if you are interested into the heavy technical details, if you want to see the entire code flow for vulnerabilities or gadgets, you can just reference the white paper later. So when I'm thinking about hardened deserialization targets, I'm thinking about targets where you, for instance, can target control the target deserialization type, but you have, for instance, an extensive block list or some allow lists. Sometimes they are very restricted. You can only deserialize a couple of types. Sometimes they are more flexible, allow you to deserialize everything from a given namespace, for instance. So it really depends on the target, right? So during the talk, I'm going to show you some new ideas that I think that haven't been presented before, especially for .NET. And also I will provide you some ideas for your research, how you can look for custom gadgets, chain of gadgets and stuff, which I hope that you're going to find interesting. So the first use case that I would like to show you is the SolarWinds platform RabbitMQ deserialization. So I have written a blog post which was published like 3 weeks ago, and I have described a couple of vulnerabilities in SolarWinds. So 2 of them were based on this RabbitMQ vector. So basically the attacker was able to send JSON.NET serialized payload to the SolarWinds RabbitMQ instance, and there was a SolarWinds information service which was taking that payload and was deserializing it. So basically there were 2 separate vulnerabilities because we were able to control the target deserialization type in 2 different ways. Also, the type name handling for JSON.NET was set to auto. It basically meant that you were able to fully control the target type. So we said that we want to deserialize object of this type, right? So it was an easy remote code execution here. So it's a fragment of the payload, right? In the TK, you provide the system object, for instance. In the V, you provide the gadget, and that's it. So during the first part of the talk, I would like to focus on the patch and how I have bypassed this patch in a couple of ways. So they have, for this particular attack vector, they have implemented very extensive block list. It contains around 30 classes, that's a lot. It implements a lot of gadgets, I think all the gadgets from Y2Serial.NET, so the state-of-the-art tool, and also gadgets that were mentioned in the Friday the 13th JSON Attacks Black Hat USA white paper, written by Alvaro Munoz and Alexander Mirosh. I'm sorry if I have misspelled names. So when we have a quick look at it, we see no bypasses, right? There are no gadgets that we can use against that, endpoint. And it made me wonder, because, for instance, if you are talking about Java deserialization, we were mainly targeting, classes. We were looking for gadgets in third-party libraries because there were almost no gadgets in the Java code itself, right? In that .NET framework, it was completely opposite. We had a lot of gadgets in the .NET framework itself, so I think we were not looking for gadgets in different places, right? Because we didn't have to. But right now, vendors, developers are more and more aware about those bugs. So we have those block lists, right? Which block basically everything that we currently know. So my idea is maybe we can look, for gadgets in third-party libraries. Maybe we can look for the gadgets in the product code base itself. SolarWinds is huge, right? There's thousands of classes. So many ideas appear in my head, and basically I refuse to think, that this patch is enough, right? So the first thing we want to do before looking for some, custom gadgets for a given serializer, we have to be fully aware of the serializer capabilities. So here we are targeting JSON.NET, and in general, you want to avoid a situation in where you are aware of like 90% of capabilities of the given serializer. You are looking for some custom gadgets, And it turns out that you would find one, but it's in those 10% of capabilities that you don't know, right? So the more you know about the serializer, the better. So for instance, JSON.NET, of course, as every setter-based serializer can, initialize the object through no argument constructor, which is public, and call public setters. But it also supports serializable interface, and its constructor, the one which accepts serialization info and streaming context for arguments. It supports some deserialization callbacks, and also it has one very nice property, which I find that we have been missing as a community for a long time. It allows you to call public constructor with arguments if it is the only public constructor implemented for the class. So I've been abusing this capability a lot during the entire research. So before I even go for custom gadgets and stuff, I've been reviewing this block list, and I have found one weird item. It's Microsoft PowerShell Editor. I was not aware of such gadgets, so I started digging, and I realized that there was a mistake in the list, right? The DLL name was used instead of the class. So the class should be text formatting run properties, and such mistakes happen. For instance, I think there was a typo in the Exchange block list some time ago, so yeah. But okay, so right now we know that we can, in fact, use text formatting run properties gadget, which is known. But if we go to the YSOSerial.NET documentation, you can see the list, and in formatters, you see no JSON.NET, right? And at this point, you always want to verify that, because when somebody contributes to YSOSerial.NET, the researcher does not have to, look at all serializers. There's a lot of them. So as we are aware of capabilities of JSON.NET, right, we can always do that by ourselves. And I've checked this text formatting run properties class, and I quickly realized that you can, in fact, deserialize it with JSON.NET, because there is this serializable constructor which you can reach, and it just leads to XAML parse method, which XAML reader parse, which leads to easy remote code execution in .NET Framework. So actually, it was a first bypass, and it was based on the mistake in the list, but the gadget was not implemented. So you always want to verify that, right? If you're aware how the serializer works, it should be easy. But I like to think about the potential patch when I find the vulnerability. And in here, it was quite obvious for me that vendor probably is going to just fix this block list item, right? Because, okay, there was a mistake in the list, but the list is still good. I mean, as long as you can say that block list is good, because in general, we disapprove the usage of block lists, right? It's not the happiest approach for fixing of such bugs. So at this point, I started to look for custom gadgets in SolarWinds codebase. And I was taking, the capabilities of JSON.NET. I was looking for classes that can be deserialized with those capabilities. And I was reviewing them, right? A lot of, at this point, it was a lot of manual work. And I have found this worker controller WCF proxy class. And as you can see, it has only one public constructor, which can be reached through the deserialization. And it has a very interesting method call. It's launch worker process. So it sounds promising, right? So at this stage, the first thing you want to do is you want to verify whether you can deserialize the arguments. So if you can control the arguments to the constructor, and of course you can control the string, which is the last argument, but we have a service operation mode, which turned out to be an enum, so it's easy to deserialize it. But we also have the worker configuration, so we have to have a look at this. If it turns out that you cannot control some of the arguments, you can always provide the null value. So the deserialization will call the constructor, but the argument will be equal to null. So if it's relevant for your gadget, the gadget won't be valid. Sometimes you can just omit some arguments, so it's okay. So it turned out that worker configuration can be deserialized because it defines a public no argument constructor, and it has a very promising member names. You can see the command line member and the command arguments member. So we are investigating further, and the launch worker process initializes the process start info, which is again great for us, and then it just starts a new process. So the only thing we have to do is we have to verify whether we control this process start info or not. And again, it turned out that we are able to control the process start info. So at the first place, we are controlling the argument, the first part of the argument, so we can provide anything here and escape the rest of the arguments with ampersand, for instance. And then we've got a path combine, where the which creates the path to the executable. So we control the second argument to the path combine, so we can provide an absolute path here or do the path traversal, it doesn't matter. So in fact, it turned out that here I have designed like the first way to bypass the entire block list with the custom gadget which existed in the SolarWinds code base. You can see the type worker controller WCF proxy and command line here. I've just used the path traversal to reach the CMD exit and I provided arguments. So there is one more important thing about custom gadgets. If you are, for instance, a red teamer and you want to be stealthy, so you can use those custom gadgets to, in the code base to go under the radar, right? Because a lot of solutions like web application firewalls detects, the gadgets that are commonly known. If you use such a gadget, nobody knows about it, right? It's in the product code base, so there's a pretty huge chance that you are going under the radar here. Okay, so I'm going to skip the third bypass because it was mainly based on the previous one, so you can find the details in the white paper. But now I've reached my favorite gadget, to be honest, because we tend to look for something that gives you direct remote code execution, like the previous gadget, right? It was simple because it allowed us to start a new process. It's the most basic thing that you may look for. But sometimes you won't be able to find those, but you may be able to find something that is based on a product functionality, for instance. So imagine a deserialization gadget that, creates a new user, allows you to execute any SQL query, right? It allows you to modify product configuration. You never know what you will find in the product code base, and all of these may appear to be useful. So in here, I have a very interesting gadget in SolarWinds. The class name is Credential Initializer, which is interesting, has an interesting name. And we've got the input argument called log config file. So there was a lot of code down beneath, but what we have to know that we are reaching this part of the code. And basically, this gadget allows you to provide a file, the path to the file with the log4net configuration, and it allows you to modify on the fly the configuration of log4net for SolarWinds. So log4net is like, log4j, but for .NET, right? Right now we have to think how can we deliver the file. So it's Windows, so we have two ways. The first one, we can provide the UNC path and load file directly from your SMB server. SolarWinds is rather the internal product. It's not exposed to the internet, and the majority of the environments you should be able to use, internal environments, you should be able to use your SMB server to deliver the file. Other way is, to chain it with legitimate file write functionality, like, for instance, upload the image functionality. There is no verification of extensions here or whatever, so if you're able to upload anywhere to the file system, you can just chain it. But I have just used the UNC path and remotely loaded the file. So at this stage, we have to think, how can I abuse the gadget that allows me, to modify the log4net configuration? And if we are thinking about logging, my first idea was like file write capabilities, because we are writing something to a file. So I've studied the log4net configuration, and I've quickly found on such a configuration. So for the file tag in the log4net configuration, we are providing the path. So as you can see, I was trying to create a web shell. The header specifies the first thing that is going to be written to the file when it's been created, right? So in the header, we can just provide our web shell payload. And the third part is the conversion pattern. So here it is set to null, and it's very important because SolarWinds, when you modify, the configuration, is trying to write stuff to your file, and it's logging stuff all the time. But when you specify the null conversion pattern, it will always try to, write empty string to the file. So it won't mess with the file that you have uploaded. So you can, in such a way, you can just write any file. And it was another way to bypass the block list with the custom gadget. And this time, it was like not an obvious one, right? So keep that in mind, because if you create a tool, for instance, something based on graph searching or whatever, which may be used for finding new gadgets, it's very good, right? But there is a huge chance that you can skip such a gadget, right? So it's always good to also perform the manual review of classes that can be used. Okay, so that's it for SolarWinds for now. And right now I would also like to talk for a second about the Exchange and the proxy nutshell, because I have found a lot of Exchange vulnerabilities that were based on this attack vector. And I would like to present you quickly 2 RCE vulnerabilities in Exchange, because here we are abusing both allowed and blocked classes, so with custom Exchange, let's say, code base. So I think it's pretty interesting. And the entire proxy nutshell vector is pretty complex, so I'm not going to describe it in details, but in order to understand the stuff that's happening here, you have to be aware of 2 fundamentals. The first thing is that the proxy nutshell, during the proxy nutshell deserialization, there are like two different deserializers. The first one is a custom Exchange deserializer, which allows you to retrieve a type, right? So we are just retrieving a type, and this type was not controlled in any way. And then this type was passed to another PowerShell-related deserializer, which was pretty powerful and allowed you to do a couple of things. So the first thing was that you could provide any type, and you could call a public single argument constructor for this type and control the input arguments. Also, it allowed you to call a public static parse method. So the exploitation for the proxy nutshell, if you were aware of all those things, was pretty simple. You could just provide the exam reader class and call its parse method, and it was an easy remote code execution, right? And that's it. So again, I was thinking about the patch, and as expected, the type control was implemented. So basically, Microsoft implemented a lot of allow lists for the type, and we were not able to deliver any type. So my idea here was, I'm going to review those allowed classes and see whether some of them can be abused. And there was a different list just for allowed generic classes, and it seemed to be a particularly interesting target because, generic classes in .NET allow you to define some internal class that is going to be used somehow somehow in this targeted class, right? So in here, I want to focus on multi-valued property and DAGnet multi-valued property classes. Basically, DAGnet multi-valued property extends multi-valued property, and it leads to the same root cause and the same code. So you can say that basically they are very similar. So what happens with this multi-valued property? So it defines a public single argument constructor which we can call with Exchange deserialization, and there is a lot of code down there, but we can reach try parse conversion method and try constructor conversion method, which sounds pretty familiar, right? Because in general, those 2 methods allow you to have this inner type defined and take the type and call the parse string method, or call the single argument constructor for the given internal type. So it's basically like the inner deserialization implemented in the multi-valued property, and it's very similar to the one implemented in the PowerShell remoting, but just a little bit less powerful. So to sum up, you can do something like this. You are calling a constructor for multi-valued property when the inner type is set to exam reader, and as an input to the constructor, you deliver the exam gadget, right? And it, in fact, leads to the exam reader parse method call, where we fully control the input to the method. So in such a way, I was able to take the allowed class, which implements an internal deserialization which had no type, a verification implemented, and I was able to abuse it to get the remote code execution. So after that, again, we can think about the patch. And my idea was that multi-valued property is not going to be removed from the list of allowed classes because it's been heavily used by the Exchange internally, but they are probably going to implement a control of this inner type that we are providing to the multi-valued property. And basically, I was right, but there was one difference. Okay, so I also wanted to show you, I'll just go back to the multi-valued property for a second, because as you can see in the payload, we are defining multi-valued property with the exam reader. So the exchange says that multi-valued property is allowed, so it's okay, right? But it doesn't verify the internal type, right? And we have this patch for the internal type control for the multi-valued property, but there is one issue. The control for the internal types for the multi-valued property is not based on the whitelist, but on the blacklist, right? And it again gives you a field for misuse. So exchange block list is pretty extensive. It contains thousands of different classes. But again, my idea here was, so let's look for the classes inside of the exchange, right? Because there were almost no internal exchange classes in the block list, so maybe I will be able to find something. And I have quickly found the command class. So as you can see, the command class just implements a single argument constructor, which allows you to start a new process. And that's it, right? So again, in order to bypass the patch, I was defining the multi-valued property. The inner type was set to comment, and as an input to the constructor, I was able to, define any command that I want to run, and that's it. So I was abusing both the, allow list and the block list at the same time. So I was using the allowed class to deliver the inner class, which was not blocked, right? So in the demo, you can see that I'm running the exploit. So those vulnerabilities can be exploited by any user with the mailbox in the exchange, so basically by almost any domain user. So we have reached the multi-valued property, and we have reached the try constructor conversion. And as you can see, our target type is comment here, right? So we have reached the reflection, which actually calls our constructor. We have reached the command constructor. And we have the definition of the process start info, and if we continue, the calc gets popped. So we got the remote code execution in Exchange. Okay, so right now I would only like to quickly mention the gadgets in third-party libraries. So I have mentioned that also we may look for such gadgets. And I don't want to spend so much time on them right now. You can find details for all the gadgets in the white paper, but I only want to mention a couple of things. So I didn't look at a big amount of libraries, only I have taken some popular libraries from NuGet, and I've taken the libraries which were used in the products that I were targeting at that time. So for instance, you can see that there are 3 remote DLL loading gadgets, and what's important is that 2 of those libraries can be used to get the remote code execution not only against .NET Framework, but also newer versions of .NET, like .NET 5, 6, or 7. And also, I would like you to, if you're interested into that stuff, you can have a look at the preserve working folder gadget. It's a very interesting one because it allows you to modify a current directory for the process and completely mess with the file-based operations which are based on relative paths, right? Because you can provide a different current directory, and it's pretty fun, and there's probably a lot of ways to abuse that in huge applications. One also thing to consider is that if you are concerned about the payload length, sometimes it's relevant, sometimes not. The remote loading, DLL loading gadgets are extremely short, so if you're concerned about length and they are available, you may want to use them. Okay, so right now, I would like to switch to a different topic, and it concerns Delta Electronic Infrastructure Device Master product. It's some ICS SCADA-based product which is used by some companies. And in general, what you have to know is it had a lot of security issues in the past. So some vulnerabilities were reported to the ZDI program by a researcher known as Kimia and another anonymous researcher. And it was listening on 2 different TCP ports, and there was now authentication implemented to this communication channel, and it was based on binary formatter deserialization, so you could just, deliver any binary formatter gadget and just get a code execution like that. So it was really simple. So time passed by, it was patched, and we have received no bypasses for the patches, and I was interested how they are going to, to fix that. So I've decided to take a look, and it turned out, that the entire architecture has changed. So first of all, the binary formatter was switched to message pack serializer, and I was like, what the hell is message pack? I was not aware of that. Then there was some deserialization, and it was verifying credentials. So they have implemented the authentication, and I have actually bypassed the authentication. It was a very fun bug because it was based on the fact that you were able to control one variable which you should not be able to control, and you could completely mess with the implemented authentication logic. So this bug is described in the white paper. You can have a look. But what is important for us is that the entire deserialization has been happening, before the authentication, because even the authentication mechanism was based on this deserialization. Then it was serializing the object again and sending to you. So, okay, we've got this message pack serialization. So I was doing this research in November 2022, and this serializer was rather unknown to our community. It has changed a little bit in March this year because another researcher has made a commit to isoserial.net and has implemented the object data provider for message pack. So, but when I was analyzing it, there was no public information regarding exploiting the message pack. So I had to, again, you have to be familiar with the serializer and know all of its capabilities. So it turned out to be ridiculously powerful, So it also, of course, as every setter-based serializer, allowed you to call an ARC constructor with public setters, but it also allowed you to call constructor with arguments. However, it's sometimes very hard to control. It allowed you to set members through a reflection, which is extremely powerful, and it also allowed you to call private setters, for instance, which is pretty unusual. Also, it implements something called typeless mode, which is a little bit like JSON type name handling, which when you have some generic member like object, you can deliver an arbitrary type, and it will be our target deserialization type, right? So we can control the type in such a situation. And this typeless mode was in fact used in message pack, but what is very important about the message pack, it tends to change its default behavior between versions. So you have one version of message pack and it works in such a way, then you switch the version and it behaves completely differently, right? So you have to consider that when you're dealing with message pack. And as I have already mentioned, the object data provider, so the commonly known gadget implemented in isoserial.net, should work for message pack, yes. But it only works from version 2.375 because the default behavior has changed in that version. And infrastructure device master was based on some ancient version where object data provider was in fact not an RCE gadget, but the denial of service gadget. So it's connected with the fact that it's, even if you didn't provide a member, it was setting the member to null. And it was modifying one of the members that you couldn't control, and object data provider was just killing an entire process. So you can find all of the details in the white paper. But at that point, I was like, okay, it doesn't matter. There's no gadgets that I can use against this message pack. I'm again going to look for some custom deserialization gadgets, right? And it turned out, that the code base is not so huge, and I failed to do so. So I was not able to find any deserialization gadget for the message pack that I could use against this product. But another idea came to my head, and it was, insecure serialization, because as I have already mentioned, you are sending the serialized payload to the to the infrastructure device master. It deserializes it, and then it serializes it again. And I find this scheme maybe not common, but present in some products, especially if the entire communication channel is based on the deserialization. So my idea was this. We are sending some malicious object to the target, the deserialization is being performed, but it doesn't lead to anything malicious, right? Because it's not a valid deserialization gadget. So the product may perform some operations on the object or not, but it serializes the object again. And during the serialization, we are calling getters, right? Not setters, but getters. And my idea was to look for, the serialization gadgets where something interesting and potentially malicious happen in the getter call. And in order, it was a conception, right? So in order to prove that it may be applicable, we have to look for gadgets. So of course we can look for gadgets in 3 different ways. We can look for serialization gadgets in .NET Framework, we can look in third-party libraries, and we can look in the product code base. And in fact, the product code base is a very promising attack vector for looking for info-leak gadgets, and I will mention that later. And also I have distinguished 2 different kind of gadgets here. The first one is the serialization gadget, where malicious stuff happens during the getter call, right? But also you can have a deserialization to serialization gadget, and in that example, the malicious stuff may happen during the deserialization, but you are not able to benefit from that if there is no serialization. So I will explain it on an example soon. And I've been able to find 6 gadgets, 3 in .NET Framework, and 2 of them directly lead to the binary formatter deserialization. So you have a getter which leads to binary formatter deserialization. Also, I have found like 3 gadgets in third-party libraries. So what you have to know about the insecure serialization, that sometimes, depending on the deserializer, it may be extremely hard to exploit that. So for instance, here we've got the settings property value gadgets in .NET Framework. You can see that we've got the property value getter, and it leads to binary formatter deserialization. And we are able to control the stuff that is passed to the binary formatter deserialization, so it's okay. And it works really good for message pack, at least for some versions. But for JSON.NET, it's problematic because during the deserialization phase, you are not able to control all the members. And before we reach this get property value during the serialization in JSON.NET, it's going to call a different getter for the member that we are not able to control with JSON.NET, and the object null reference exception is going to be thrown. So if there is no exception handling defined for JSON.NET, it may be hard to abuse that. Another example in .NET Framework is the security exception, where again the get method leads to the binary formatter deserialization. So security exception has been already referenced by Soroush Dali in one of his white papers regarding the potential things that in .NET Framework that lead to binary formatter deserialization. Again, it's very hard to use it again during the serialization because you have to chain some different kind of a serializer and deserializer. So I have explained all of this in details in the white paper, so don't want to focus on that right now. You only have to be aware that there is such a gadget, and also I will later show you how you can abuse it in a different way. Also, here I've got an example of a gadget in Apache NMS ActiveMQ library, where again the getBuddy getter leads to the binary formatter deserialization. So I was able to abuse it in one of the products. And in here we've got an example of deserialization to serialization gadgets. So it exists in Amazon AWS SDK core library, which is pretty popular. And in here, during the deserialization, we are reading the content of the file. But when we are not able to benefit from it if there is only a deserialization, right? But if this object is getting again serialized, we are receiving such a JSON, right? And as you can see, the JSON contains the content of the file, right? So if we are able to change deserialization and serialization, we can abuse such a gadget, for doing a file read. So right now I would like to quickly show you example for InfraSuite Device Master. So as I have mentioned, the settings property value gadget could be used against message pack. So in here, I'm running the exploit. We have reached the deserialization and nothing happened, right? But right now we are at the serialization phase and we are reaching the binary formatter. So I was able to get the pre-auth remote code execution by, by just using the serialization gadget, right? I was not able to get a pawn through the deserialization, but as the object was again serialized, I was able to get the code execution directly through the serialization. And it turned out to be nice, right? Because I was not aware of, any deserialization gadgets. So in fact, you can use those serialization gadgets when there is an extensive block list, for instance, that you are not able to bypass, or you are not aware of any gadget that you can use against the target. So another example of insecure serialization is in SolarWinds RabbitMQ, which I have analyzed in the beginning of the talk. So I didn't mention to you that you are able to force the SolarWinds information service to serialize the object again after the deserialization. If your object is stored in one of some SolarWinds-based classes, it serializes it again, and it puts it to SolarWinds RabbitMQ, and you can extract that from the SolarWinds RabbitMQ, right? So I was not able to find any direct remote code execution serialization gadgets here, but we have those info-leak gadgets. So in fact, I was able to use 3 different gadgets here. The first one was the gadget in the Amazon optimistic log text file, which I have already showed you. SolarWinds uses this DLL, so you could use that to do the file read. Another example is the internal SolarWinds gadget, which allowed me to leak database credentials. So that's the stuff about, the internal code base and serialization gadgets. A lot of products implement like a class which has a getter, which retrieves database credentials, right? So if you have insecure serialization, you can use that to, leak the entire, for instance, the database connection string and do some stuff if it's available. And the last gadget was, in fact, the internal SolarWinds serialization gadget, which also allowed you to perform the file read. So you can see the code. We have a constructor, and through the constructor, we are able to control the file name. And there is a getContents method, which just reads the content of the file and returns it, right? So my idea here, and I'm familiar with SolarWinds, I was aware of, the file read assistant to RCE primitive, because SolarWinds has an Erlang instance deployed on all interfaces, and it's protected with some secret that is stored in the file. But if you have the secret, you can just connect to the Erlang and execute anything you want, right? So it's the last demo for the serialization. So I'm running the exploit in the SolarWinds, and you can see that right now we are at the deserialization phase. So during the deserialization, we are reaching the constructor for this SQL file script, right? And we are trying to retrieve the file which stores the Erlang cookie, and we have reached the serialization. So during the serialization, the file content is being extracted. And if we continue the exploit, after some time, we receive the file, because the serialized payload was sent back to the SolarWinds RabbitMQ, right? So I have just extracted the serialized payload. So here's the cookie. So right now I can just, take this cookie to connect to the SolarWinds Erlang and execute any command. So that's an example of another, like non-direct RCE gadget. But if you have nothing else to use, so you are just desperate, you are looking for anything, and you never know what you will find, right? So that's it for the insecure serialization. But what if I would like to use insecure serialization gadget, but there is no serialization? So I was thinking about that. And you may be aware that Alvaro Munoz and Alexander Mirosh has already presented a long time ago one arbitrary getter call gadget, right? So in fact, our insecure serialization gadgets are based on the getter call. And my idea is maybe we can just chain the arbitrary getter call gadget with our insecure serialization gadget to trigger like the serialization like behavior directly through the deserialization. So it turns out that the presented gadget does not work anymore. At least for me, I was not able to use that. You can find the details in the white paper. So I decided to look for new arbitrary getter call gadgets, and I found 4 of them in .NET Framework: property grid, combo box, list box, and checklist box gadget. So the entire idea for it is like you have an insecure serialization gadget. you take the arbitrary getter call gadget, you chain them together, and you're deserializing the serialization gadget, and then you call the malicious getter, right? During the deserialization. Of course, it has some limitations in contrary to the regular serialization. So you cannot use them for info leaks, file read and stuff because you are not getting the object back, right? The serialized object back. I assume that vendors are going to start blocking it in the future, so you may need to look for new gadgets or wait for just something that performs the serialization directly. And for JSON.NET, it does that work for type name handling set for a member only, so you have to be aware of that. If you are interested in technical details why it does not work, you can check them in the white paper. So here is an example of gadget. So we are using the property grid arbitrary getter call gadget and chain it with the security exception serialization gadget. So we can see that in the first part of the payload, we are defining the property grid gadget. And to its selected objects member, which is a list of objects, we provide the security exception serialization gadget. In the method member, we define a binary formatter gadget, and we pass that to JSON.NET. So JSON.NET basically, deserializes this security exception through its serializable constructor, and it sets this method-related member to our binary formatter gadget. Then it's going to pass it to the property grid selected objects setter, which in fact leads to the getter call, right? It will call our get method, which leads to binary formatter, and we can use that to get the remote code execution. Another example is the combo box chained with settings property value gadget. So in here you can see that we have a combo box defined. It has an items member, and in here we are defining the settings property value serialization gadget, and in the serialized value member we are providing our binary formatter gadget, and then we just say to combo box, call the get property value. So it will deserialize settings property value, and then it will call its get property value getter, and again we are getting the code execution by chaining arbitrary getter call gadget and the insecure serialization gadget. So what I want you to know is that you can look for those insecure serialization gadgets in the product that you are targeting and chain it with those arbitrary getter call gadget, and you are extending your entire exploitation surface, right? Because you don't only have to look for those deserialization gadget, you can look for dangerous getter calls and just chain them, right? Also, very interesting gadget, it exists in the third-party library Microsoft Azure Cosmos. It's a deserialization gadget which triggers serialization. So during the deserialization, you're providing any object, and this library is going to serialize it with JSON.NET. So if you have a block list which blocks a lot of stuff, you can have it in mind, like you can trigger the serialization directly to through the deserialization, and perform another chain of gadgets and something like that. So I believe it's an edge case, but you never know what may be useful for you in the future, right? So in general, I have found a couple new deserialization gadgets in .NET Framework. So we've got this chain of arbitrary getter call gadgets and insecure serialization gadgets. Also, there is another RCE gadget called XAML image info. It's a pretty complex one, so I have described it in details in the white paper. You can have a look because it accepts an abstract type in its constructor, and you can abuse it with JSON.NET, for instance, but it's not so easy, and it's quite an interesting technical case. Also, I have found, non-RCE gadgets like picture box, which performs server-side request forgery. So you can use it sometimes like URL DNS for Java, but it's a little bit more powerful because it actually allows you to perform the request. And you can use different protocols. You can use HTTP, you can use FTP, you can use file, so anything, right? So I'm going to skip some image info. You can find details in the white paper. And I just want to quickly mention that if you are aware of a lot of different gadgets and you can chain them, you can bypass block lists pretty quickly, because in here you've got a patch for this infra-suite device master after I have exploited it with this insecure serialization. So as you can see, the settings property value which I have used against it was blocked, right? But I didn't care because I've just taken the arbitrary getter call gadget with property grid, and I have mentioned that there is insecure serialization gadget in one of Apache libraries, and this library was used in the product, so I just chained them. I've chained, this getter call gadget and insecure serialization gadget to bypass this block list in like 2 minutes, right? So the more gadgets you know, the more you know, the biggest is your attack surface, you know how to chain them, the easier it is to, pawn those targets. And the last thing that I would like to show you are the gadgets in .NET 5, 6, and 7, because as community we are not aware of many gadgets for those versions of .NET. I mean, they are not frequently used in products right now, so that's why we are not looking for them. But in general, if WPF is enabled for .NET 5 and bigger, because it's not by default, you can just use Object Data Provider. It works, right? But I believe that it's been frequently blocked by everything because it's one of the most popular .NET deserialization gadgets. But I have found 2 remote DLL loading gadgets, base activation factory and compiler results. So the base activation factory, in fact, leads to the kernel 32 load library XW. So while looking for deserialization or serialization gadgets, also take native calls, into the consideration, because there are a lot of native calls in .NET and in the third-party libraries. So of course we can provide UNC path here and load remote file or chain it with some file write functionalities. But here we have a very fun gadget called compiler results. And it's in fact insecure serialization gadget, right? Because we have a getter and we have the assembly load file call here, and we fully control the path. So, it was pretty weird for me to find out that in .NET 4, as you may know, the remote DLL loading was blacked for assembly load file, load from methods, and then different similar methods, right? So I was like, this gadget is not very interesting, right? We can, of course, chain it with the arbitrary getter call gadget. The same gadgets that I have shown you work also for .NET 5 and higher, but you need to have WPF enabled, right? So without WPF enabled, you can use this as a serialization gadget. With WPF enabled, you can chain arbitrary getter call gadget in this. But regarding the remote DLL loading, I was like, it should be blocked, right? But I will still try it, and I was like, what the actual hell? It worked. I was able to remotely load DLL through the assembly load file, right? And I was like, what happened? So I've checked the documentation for .NET 7, and the documentation clearly says that you should not be able to remotely load DLLs with those methods. So we have reported it to Microsoft, and after some time, Microsoft told us that it's an expected behavior for those versions of .NET, and they are just going to change the documentation, right? As you can imagine, it never happened. At least I have checked like 2 weeks ago, and documentation for .NET 7, 6 still says that you should not be able to load remote DLLs with those methods, but you can. So it's like, deprecation of a security feature. So if you are targeting those versions of .NET, have that in mind, that you can load remote DLLs with assembly methods. Okay, so just to finish, I would like to tell you that I have implemented all those stuff to ysoserial.net. So we have like 5 new gadgets in the mainline of ysoserial.net. I have also implemented text formatting run properties for JSON.net, and I have implemented 3 plugins. So the first plugin implements arbitrary getter call gadgets, so you can provide any insecure serialization gadget that you have found, for instance, in the product code base, and use this plugin to chain it with this selected arbitrary getter call gadget. I have also implemented a plugin with gadgets for third-party libraries, so the remote DLL loading gadgets and stuff. And also I have implemented a plugin for .NET Framework non-RCE gadgets. So for instance, the server-side request forgery gadgets. So if you are planning to look for some gadgets in the future, right, and you have any gadget in third-party library, I encourage you to, to commit to those plugins. So the entire pull request is going to happen on Monday when I get back from the conference. Also, the white paper is going to be published on Monday, so sorry for that, you have to wait to 2 days when we get back from the conference. So thank you very much for the attention. I hope you like it, and I hope that you will find this research useful during your research. Thanks.